Okay, Crewton Ramone, Part 2. Colby Completes the Square. And I was saying, and before I was so rudely interrupted by the clock, that this right here is a great example of the child moving from pictures and drawings to the symbols because they're lazy and it's faster to draw the symbols. Much easier. And you can see here, right, we have a combination of picture and symbol, where I have the x and 4 is the same thing as plus or minus 5. So we have this over here, and this, anyway, and then next, and I don't think I got a picture of it, you very easily see that x is the same thing as 1, right, because obviously 1 plus 4 is 5, and negative 9. As an aside, when I was in school, I always missed this one, because I always forgot about one of them, right? I always got the positive, but I didn't always get the negative because I always forgot about the concept of plus or minus when it comes to square rooting. Okay, anyway, so let us continue. Here is one. Like I said, I just went around the internet and pulled a whole bunch of problems off and show how easy these things are. X squared, and again, look at this kid. He immediately sees like 16x and minus 57, right? I just changed the problem a little bit. There's our 57 over here already moved over, right? Positive. Of course, he grabbed 16x with 2, right? We've got some multiple 10s here, and he grabbed 2 sets of 8 to make 16 because he knows he's going to have to complete the square, and he already knows that he has to cut that in half. So that's going to be 64. So if I add 64 here, we understand the concept that in order to keep this an equation, I can't just add anything over here because then I'm not equal anymore. So I have to add the same thing over here. And there he is replacing 57 with 120 because he did the math in his head there. And there he is. He was about to build it with a couple of 10s, but he took the green 10s because he likes the green, and then the green 1, and then it looks like it's got a green band around it, and he thought that was cool. See, he's being creative, right? Just like when we were building the 25 with the 9 and the 16 and putting the 9 in the middle and the 4s around the edge. Well, here, same thing, right? You got to have a little fun in there while you're doing it. Okay, so now we can see again that all this scribble scratch up here, you can definitely tell that he's doing the writing. And there's the title of our screencast. It's Colby Completes the Square. Is x squared 16x and 64 when I right? The whole point of doing this is so I can get x plus 8 squared. And over here is 121. He knows, like I said, 121 super easy. And if you recall from the beginning of this video, or beginning of screencast 1 of Colby Completes the Square, this is in algebra, so we've come full circle around. I like the way I do that. Okay, so now we're using base 10 blocks. No, before this was an x squared, 2x, and 1. There's a method to the madness. Really, there is. Okay, so now we have, and also I want to make it clear that you need to understand that it makes it so much easier when you know where you're going, right? You have confidence, you know what you're doing, but you already know pretty much where you're going to go, right? So in problems like you saw in the first screencast, the idea is to make it simple, and we're just getting the idea and the concepts down, and then, like I said, we can go forward fast and solve these problems pretty much as fast as I can stick them on the board for when I'm doing demo teaching in classrooms, is as fast as the students can solve them. I mean, they'll start doing it because that's how fast the human mind is. It's a supercomputer once it's trained and it knows what it's doing. And I see all kinds of questions on other places about, do my kids need to bring the blocks to school with them? And won't they become block dependent? And what happens when my child... Look, I'm telling you, if you use this method, these kids will get to the point where they don't even need the symbols, right? They can see this and bust it out in their heads without even having symbols, especially if you get them when they're young. You get them when they're in college or when they've been a teacher for 16 years, then you're going to have some problems. And adults and parents too. But I'm telling you, 100% from experience with kids, that once they learn this method, they A, understand what the symbols mean, and B, don't always even need the symbols in order to do the computation. which, by the way, if you read some of the articles I've written, computation is not mathematics, right? Computation is how we do mathematics, but let's not get bogged down in computation and rules and process. Okay, so there is a close-up where we see that he had the x plus 8 squared equals 121, nicely written out. He almost put an x there because he was thinking that it was the same x squared, 2x, and 1, but then he remembered he was in base 10, so he turned that into a regular old 121. And there is, we're at pretty much the end of the class here. And we find that x plus 8, again, didn't put the square root symbols. We know that what we're doing, we understand the concept that one side of a square is this, and one side of the other square is this, and that's the same thing as square rooting, right? And in fact, all the sides of this rectangle are x plus 8. And because it's not just any kind of rectangle, it's a square, and squares are 4 equal sides. Same thing with this. Any side of this one is 11. I just want to bring that point home. So now all I have to do is I have x plus 8 is plus or minus 11, and the one answer is very simple, but he's actually a little overwhelmed with all the symbols and everything we were doing, and he was hesitating to figure out what plus 8 is the same thing as 11, because what he was trying to do in his mind actually was what I had showed him, making the hero 0 over here. And so he had 8 plus 8, and he was doing that. And then his little brother walked in. And his little brother, who's 8, said, I asked him, what's x plus, what plus 8 is the same thing as 11? And he looks at me with a big smile and says, 3. Nothing hard about that. Okay, so then he puts it in his notebook and he figures out that the other answer is negative 19, right? Because negative 19 plus 8 is the same thing as 11. And the way we got that, again, was by using our hero 0 and having a positive 8 and a negative 8 over there. And when I take away the two positive 8s, I wind up with negative 11 and a negative 8, which is, of course, negative 19. And the other way of doing that, and if you need to, go back and look at the first video if you haven't seen it. I would assume you have, that you wouldn't be watching part 2 without having watched part 1. But when we were doing the other part, the thing he was trying to do in his head, which actually turned out to be more complicated than just thinking 3 plus 8, was there's an 8 and a negative 8 over here. And when I take away the two 8s, what's left over here? Well, 3. Okay, so because of the combining, how did I get that? Well, when I have plus 11 and I have 8 here, it's basically the same thing as subtracting the 8, right? I take hero 0, subtract the 8 from both sides. You'll see that I have an autistic student that's her preferred method of doing it. She just makes a 0 here by subtracting 8 and then subtracting 8. He was trying to use the method where we find same on both sides, and what's same on both sides is going to be the 8, right? Anyhow, okay, so and when I take away 8 from that 11, I'm left with 3. Here is the drawing with the 64, and see here they corrected it and still hadn't erased it there, but here we see the 8, or excuse me, the x plus 8 squared equals 121. And so there is the big square, and he didn't have room because he drew it so large to stick it, it's better when the two squares are side by side and they can see it. But anyway, the idea is that he drew a picture that's 8 here and 8 there, right? X squared plus the 8x plus the 8x gives me 64, and this is just 121 now, right? This is 100, 2 tens, and 1. So it's easy to see that one side is x plus 8 equals 11, which is what we have there. Alright, so anyway, just understanding that the drawings and pictures mirror the symbols. Right? In fact, you start off in the concrete, move to the pictures, and then go to the symbols. That's the way to do it. And now when we see the formulas that some of the teachers try to start with, they completely and utterly make sense. So anyway, here again, like I said, we go back, and now what? Look at that. That same drawing means x squared 2x plus 1. Right? So we definitely have to know what the context is. And I don't know if I mentioned this in the other video, but I thought this was pretty funny. Because, you know, if you're going to use symbols like this, we need a key. I was like, what? Because, no, you have to have a key, so you know what's going on. So that dot means 1, and that square like that means a negative 1. So we made a little key. I just thought I'd throw that in there for the sheer enjoyment of it. Now, we've gone on for 25 minutes or more on completing the square and understanding the basic concepts. What do we do? What we do to start off with is we take this, right, move it to the other side, whatever it is. Well, on this one we don't because we already have the square and we're just solving. But okay, on this one, we take whatever this is, move it to the other side, right? And instead of factoring, we complete the square by adding a 9, and so whatever we add over here, we combine with what's over here, and then we square root, and then we solve for x. That's all it is, every single time. That's the basic concept you're dealing with. That's completing the square. Okay, so now when you give them the symbols, you know, with ax squared plus bx plus c, and they understand taking 1/2 of b and replacing it with c, and so, okay, now it makes sense. Okay, so now we can move on to problems like this. Now, these problems here were given as, in some cases, like I said, as I went cruising around the web, as introductory problems. This is how we're going to introduce the concept of completing the square? Not. Now that we've done everything that I just did, right, with that one kid where we've spent several hours on it, now we're ready to do this, right? I mean, come on. This is more advanced algebra, right? Quote unquote advanced is not when you baby step your way there. But I mean, do you really want to start off with this, where this coefficient is negative? I mean, it's easy once you understand, you know, and you've done factoring and so forth. But still, do you want to start off negative, right? No, start off positive. That's just my personal. And then I had this other teacher, watching him do this, starts off with 18 here. Why not start off with 9? If we start off with positive 9, then when I add my 25 to both sides, this would be a negative 9 over here, so that positive 9 would be in here. So this would be negative 9, and I would end up with 16. Or I could start off with negative 11, and then when I added 11 to this side, I'd get 11 plus 25, and I'd have 36, and then I'd have perfect squares, and it'd be a lot easier to understand the concepts, because they're already dealing with, you know, not understanding why I divided this by 2 and then multiply by itself and get 25 over here, because they can't see the symbols. So, anyway, and then a problem like this, why not just, man, this is a great one for quadratic. This is like a perfect example of why you would use the quadratic equation. So simple, just plug in the 6 for A, the negative 7 for B, and the negative 3. Okay, fine. You want to use it as for completing the square to make sure they understand the concept, and you're going to have all kind of wondrous fractions in there, because I got to take 7 divided by 2, and then square it, and then add it here, and then I wind up putting it over here, and right, oh my goodness. So yeah, there's a lot of fractions involved. Fortunately, the teacher was nice enough to make sure that it worked out nicely, and it was actually fairly easy. But most students are going to freak out when they see the fractions. They really are. It's no fun. So why not just use the quadratic? But anyway, if you're going to teach and get the, you know, winding up with what, 100, I think by the time it's all over, it's 121 over 144, because you wind up with 1/2 plus 49 over 144. Anyway, geez. This problem is a great problem, and I'm running out of time. And so is this one, where you have to do the, right, square it out over here, and then combine, and then you wind up with a problem, or, you know, you have to combine like terms and so forth. This one right here, awesome, because it makes you think. Look, none of this is square, none of this is easy, none of this is even, but to do so, and it's going to work out nicely, trust me. I could multiply that by 3. Why do I want to multiply it by 3? Because it's completing the square, so I need to turn this into a square. But then when I multiply by 3, I got 15 over here. Oh, what a pain. So now what? Oh, what if I multiply by 4? So first I multiply by 3, then I multiply by 4. Now I have a square over here, that's 36, that I can put my 60 around, because I multiplied by 3 and then I multiplied by 4. Right? And see, I'm doing this in my head, but I'm looking at a picture. I'm looking at a geometric figure. Right? And it makes it so much easier when you can see what you're doing. Want to see these? Get yourself a password from Crewton Ramone's House of